So Chris asked me to jump in here and provide some info on this because I've been involved in lots of crazy substrates over the years, and gypsum seems to keep going through another realm of situations that we've come into in recent years. It was kind of like it went away for a while and then it's come back. And so my goal here is to try and, depending on what, no matter what you are and what your function is in our industry, whether it's an installation or supply or technical, at least give you a little bit of information and some things that we've been able to do and some background on it, and at least get something out of this for the next 30 minutes. So yeah, I've been in the industry pretty much all my career at a variety of levels. And what I like about this industry is there's just so many things to learn, and you just keep learning with a lot of the changes that we have in the industry. So let me jump into it a little bit here. So one thing, and no matter whether you're talking about a gypsum substrate or a plywood substrate or concrete, like there's some things that remain the same that can make or break an installation. So I want to just preface by getting into that a little bit here. So the first thing we need is we need a substrate that is dry and free from moisture. And when I talk about moisture, primarily what I'm talking about is moisture vapor that can affect a floor covering, and something that is sound in nature, that is acceptable to the performance standards of our manufacturer, so that the floor covering can properly perform. Another part of the pillar of success is we need something that's flat in plane, so that if you've got joints or connections in the floor covering, or you've got flash coving or something of that nature, that the floor sits properly flat in plane. Then if we're gluing the floor and it's not a floating floor, then you need to have the best adhesive. And there's lots of different types of adhesives in the marketplace, and some perform better than others, but you have to have the best adhesives with the best shear strengths and the best performance for the type of installation you're doing.
Dave, is it fair to say that with gypsum substrates, when you're looking to go over top of it, if you're gluing the floor down, that's when your problems really start, because floating floors obviously just rest on the surface, right?
Well, for sure, gluing is important. It's just a part of it, but also what we're sticking to and some of the soundness, and I'll get into that a little bit here as well, Chris, is pretty important and pretty crucial to the whole system in general.
By soundness, do you mean acoustical issues or the structural sound?
So I would say, well, yeah, good point. It's when I mean sound, it has nothing to do with sonic qualities and has everything to do with how strong the material is and how well it will perform.
Gotcha.
So, and then lastly, of course, we have another pillar here. Actually, our fifth pillar is our Nfca manual. And there's so much good information in here. Unfortunately, we tend to look at this manual when we have a problem, but there's some great specification documents that have been written in here. Although it's a 2006 manual, it's still very, very prevalent and valued to, if you're looking for recommendations or standards. This is a fabulous manual. I just had to put that in there, Chris.
Just let me qualify something. 2006 was the last time the hard copy was published. It's now an online version, which is updated on a yearly basis. So the current version is essentially this year, 2021. And all members of Nfca get that included in the membership for all staff.
Nice. Okay, so let's talk about gypsum a little bit here. And been used for decades. It's not new to our industry for sure. Some of the advantages is weight. They've got fire and sound ratings with these assemblies. They're typically thinner than a concrete pour, so that's another part of the weight factor, that you're not pouring it 6 or 8 inches thick. But one really key thing with gypsum is it doesn't shrink. So it's not prone to shrinkage cracking. You could still have some structural cracking, maybe because of lack of support or lack of thickness. But as far as the material, it actually doesn't shrink. So you can get reasonably uniform floors in there. So, and by the way, if we have any people that are in the gypsum industry, just know that I'm not here to throw stones at it, but we do have quite a concern with the floor covering industry because of bad jobs that have been out in the past, and it does have a bad name. We went through a cycle where manufacturers wouldn't recommend gypsum be underneath their floor covering. So, which it depending on what you're doing and what you're involved in, there could be a concern. So I want to talk about that a little bit here. So with gypsum, it's depending on what you're doing and what you're getting. So for example, my company makes a gypsum underlayment, and that is manufactured in a production facility that is computer controlled and has a quality control program to it. So, and my company does, and other companies have these type of underlayments. But typically when we're talking about big pours, when we're talking about, say, multi-residential, 5-story buildings, or they could be care homes in big facilities, typically what you're getting is a gypsum contractor that buys a concentrate in a bag form, and then he mixes it with aggregates on site and then pumps it in place. So I can't necessarily speak for the quality control process that those contractors provide in these type of applications, but it's important to know that this is how it's done. And depending on how those aggregate and the manufacturer of the gypsum, I'm sure, has a aggregate design that they recommend in order to achieve the compressive strengths that are necessary on that particular design mix. But it's a question whether, how are these, does the gypsum contractor actually take coarse samples from their material, or do they take batch samples? Like, this is part of it, and what may be specified for this particular underlayment may not necessarily be the case when it actually gets poured. So that's a question for the gypsum contractor to know what his quality control processes are going into it. But anything that is pre-blended and pre-manufactured by a manufacturer, then they will have a quality control process. Okay, so when we look at our pillar for dryness, then the same thing holds true whether you're talking about a concrete substrate or whether you're talking about gypsum. So gypsum is also activated by water. So water is put into the pump, and it's part of the hydration reaction or the chemical reaction that takes place with gypsum pour is very similar to concrete. So you've got a water content in there that has to evaporate. And in a lot of cases, these gypsum toppings also, they will have a membrane underneath them. So they could have a sound control membrane underneath. So all your moisture is going to go straight up. So you've got an evaporation process that takes place no different than a concrete pour. So now we have to test for moisture. And the one thing that is common in all of these is our ASTM standards fall through with both of this application. So the only thing that differs in the case of doing, say, a gypsum pour is that you've typically got a thinner pour. So you can still do the probe testing, and the manufacturer of the probe testing will say typically your 40% is still applicable, but your probes are going to stick up a little bit higher out of the substrate. So that's the only thing you have to know there. So you can still do a probe test, but also understand too, if you've got a radiant heated gypsum pour, then you've got to be extremely careful, obviously, that you don't hit a hydronic line, or if it happens to have electric heat, you got to be careful you don't puncture it there. So that's where the calcium chloride topical test could work better in those applications. And there's also surface meters, although the surface meters are not an industry standard, they're still very applicable for you to do some quick non-destructive testing to get an idea of where your moisture levels are. So this is something that, even though it's a gypsum product and it's thinner, you still have to go through the process of doing moisture tests.
So a quick question for you, Dave. When you go back to the relative humidity test, when you said 40%, you're talking about depth.
The depth,
40%.
yeah, your core depth, exactly. Thank you.
Yeah, okay.
Because if you, let's say you've got an inch or an inch and a half of gypsum, it's a whole lot thinner than, say, a 6 or an 8-inch concrete slab. So you've got less depth to work there. So your core test is going to be not quite so deep, and your probe is, you know, like your insert sleeve is only, say, an inch and a half. So when you insert your probes, they could be sitting a little bit proud and a little bit high out of it, but you'll still get the reading that you need.
Yeah.
Okay, so the next thing is these job site conditions, you know, and like I mentioned, a lot of this gypsum is poured in multi-residential facilities. So like everything is fast-tracked in our industry, and we're dealing with all kinds of different crazy site conditions. Like, you know, this photo here at the bottom is one that I walked in on where, you know, here it is like March, and we've got driving rains coming in. We haven't enclosed the building envelope entirely. We've got these AC vents sticking open. We've got water leakage and water ingress getting in through it. You've got single-digit temperatures in those particular rooms. You've got a new pour that's got moisture still in it that's trying to evaporate at these cooler temperatures. So, you know, site conditions are still a major challenge. Doesn't matter if it's a concrete pour or a gypsum pour, the same thing holds true. We have to have proper site conditions before we install floors. And one thing that I carry around, and as do a lot of contractors, is these electronic digital temperature, you know, laser tests that you can get a pretty quick and easy test of what your slab temperatures are. And, you know, we can do all kinds of preparation work. Like we can do patching and we can do self-leveling at 10 Celsius, 12 Celsius, 13 Celsius. We can do all those kinds of things. That's not a big deal. It's when we get into the actual flooring installation, you know, when we get into installing floors, we got to have proper temperatures at 18 Celsius or above. Because if we're trying to install a floor at 13 Celsius, like that's 55 Fahrenheit, and material gets very stiff and very brittle at those type of temperatures. It doesn't contour with the substrate as well. It doesn't lay as flat. It doesn't seam nicely, and it doesn't react properly to heat welding. So really, really important that when we get to, you know, the preparation stage, we got some flexibility there to go a little bit lower. But as far as the actual flooring installation, it's very, very critical that we have proper site temperatures during those installations.
And then when you glue it down cold, essentially, to a surface, a gypsum surface, which may be borderline acceptable, borderline powdery, the floor is going to warm up as you raise the temperature in the building, and it's going to expand and stress that bond to the surface.
100%, Chris. And the more variations you have, like I looked at an installation of LVP last year that was installed when we had that really cold Arctic blast and the slab temperatures were cool, and they had variations of up to 3/8 of an inch in like 4 feet. And you can't expect plank to sit flat when you have that much variation and that cool a slab. It just won't handle it, and you get peaking in the material. It wants to go up. So very, very important is your installation temperatures. So, you know, when you get into some of these gypsum pours, like there's different compressive strengths the manufacturers of these materials have. And, you know, they have some, you know, you can make gypsum like 5,000 and 6,000 PSI. Like, so it doesn't always have to be low PSI, but so often we come across situations, and even within the same building, you could get potential of variation on one floor where it's soft like this, and you can just take, one quick and easy. I mean, we used to have car keys back in the day, but now we all got key fobs for our vehicles. But, you can take something that's not too sharp, because you use something sharp, you can just about dig into anything, and it's not totally realistic, but something not too sharp. And you see these kind of things happening in it. And whether this is a concrete floor, we get this even on rainout slabs that we have here in Vancouver with all the rain that they have during pours. But, you take something like this that's not too sharp and you drag it across the surface, and you can check to see how hard it is pretty quickly. And if you have areas like this, this is a concern. Like, we have to have a hard enough surface in order for our products to perform, and our products to handle surface traffic, and for floor coverings to properly rebound, right? If you don't have the right compressive strength, and our industry is looking for something in the neighborhood of 3,500 psi or greater. Well, if you have a floor that's 2,000 psi, well, it's way beyond underneath the specification of our manufacturers.
So Dave, you can buy a product pre-manufactured in the bag that states this is a product designed for 3,000 psi or 3,500 psi, and so then you take it to site, you mix it wrong, or you present the wrong conditions, and you can turn that 3,000 psi product into a 2,000 psi product in a heartbeat.
Absolutely. So the question becomes, was it specified? Did the owner or the architect or the general contractor get the right PSI for the floor covering and for the building? Or was it under spec because of maybe water ratio or placing or these other things? And this can happen on self-leveling mixes too, on cement-based mixes.
So the minimum standard, I think, that we all worked out when we sat on that committee to update the manual, the Nfca manual, we stated 3,500 psi was a minimum for resilient or vinyl rubber type flooring.
Yeah, exactly. Like, the ceramic industry can be quite a bit lower. They've used dry packed mortar beds for years and years and years, and ceramic tile to a certain extent acts as a bit of a snowshoe effect on a floor, but resilient flooring is completely different. So yes, agreed, Chris, 3,500 PSI is what the industry standard is typically.
So very stressful. Sorry, one last point, and then I'll let someone else dive in, but very stressful for the owner and the architect who specify 3,500, but they have no idea what's going on with the mixing and application of this product on site. And so maybe you go to site and you're watching thousands of feet being poured, and no idea, is this actually going to set up at 3,500? What do you do? We were talking about the cube test is one way to overcome that stress.
Yeah, so you could do a core test, and you could hire an engineering testing company like a Metro Testing, and they could do core tests, and they could, double check that. They would run it through a machine, and they would have they would take the depth of it and run it through a machine and put a compressive test on it and check it. I mean, obviously there's a cost involved in doing that. Like, say, the contractor, every so often, whether it be on every floor or every few rooms or every few hours, takes a little bit of material out of his pump and keeps that aside for a testing company to run a compressive on.
So you could have 100,000 square foot pour, you can pour a portion of it, do a cube test, and then know that it's worth continuing to do the bigger picture before you waste thousands of dollars having to fix a pour that's the wrong compressive strength. And we just see it all the time. It's just a disaster.
Yeah, because you could have, let's say, a pump that's calibrated for the right water ratio for that mix, but if the sand got all rained on in transportation or on the site or in other parts of Canada where sand gets frozen because of cold temperatures at night, how are you to know 100% what you're getting, right? It's not like it's coming from a mixing hopper in a manufacturing facility. It's site mix, right?
Yeah.
So
Good
so
point.
how do you check? So you can get one of these little Schmidt hammers, and these are little thumpers, and they can give you an approximate compressive strength of what you're dealing with. And they're a pretty quick and easy pressure test, and you just, push it down into the substrate, and then it kicks back into this little graph, and then that corresponds to what your approximate PSI is. So rather than doing a cube test, this is another way that you can get some quick and easy approximate values. Are you dealing with 1500, 2000, 2500, 3000 PSI types of compressive strengths in your slab?
How long before this test becomes meaningful, since day one of pour?
Probably 28 days after.
Okay.
Yeah. Okay, so moving along, that's not uncommon. We've got to do some type of prep, but also this is not to say that all gypsum is bad. So here's an example of a floor where the gypsum was in pretty good shape. And what we're using here is a primer. So you can see it's a little bit hazy there, kind of that light green kind of effect. And the guys had to do some patching and some preparation. They were a little low around the toilet connection here, and also just to smooth it over. So they had to patch. So why are we priming these type of things? Well, primer does a few things. So we know that the gypsum industry is supposed to prime their substrates, but that's not necessarily always the case. And also with construction traffic, reality is that construction traffic can beat up these primers pretty good. So what we're doing here is priming with, in this case, a water-based primer. It's just, rolled on or brushed on. And what it's doing is a couple things. So, or a few things anyways. It's killing any dust. Like, primers do a great job of binding dust particles that are on the substrate. It is also killing porosity, and typically gypsum, just like lightweight concrete, is very thirsty. So it can pull moisture out of your topical materials, whether it be adhesives or whether it be patching compounds or leveling compounds. And then lastly, and some people don't know this, is that when you're putting a Portland cement based patching compound on top, that Portland cement has the potential of reacting with the gypsum molecule and fighting. So what you're also doing here is, by priming, is that you're isolating the two materials from each other so that they don't fight. So it's kind of a bit of a barrier in here, but you're still allowing for good mechanical adhesion between two things. So we always say, always, always, always prime. Okay, so now we start getting into questionable soundness and the flooring installation. So here's a job I got called into, and the floor covering contractor, they were sharp enough that they actually started to do some of their own bond tests. They could tell that they had a potential problem. So they started with some of the bond tests, and my phone rang and said, you know what, we're having a hard time sticking to this. And so we tried a variety of different priming techniques here. So we tried the adhesive direct with no primer. And then we tried some different variations of water-based primer in different dilutions and different, coats. And in all cases, we couldn't stick to the substrate. It was just this chalky surface, and the adhesive would just ball up and just peel off the substrate. So the most important thing here is that the dealer was involved. They started doing some of these type of very simplistic basic tests to see you know, what's our comfort level sticking our floor here? So if this is the case, where do you go next? Like in some cases, we've done tests and the adhesive works fine. No primer necessary. In other cases, then a water-based material can also work. And then in some cases, we have to go to another level. So what's that next level? So what we had to do on this particular site, and there was probably 60,000 feet of LVP going into this particular job. So it was pretty significant. It was 5 stories. And we kind of figured our PSI strength was somewhere around the neighborhood of 2,000. And so what we did here was we went to a polyurethane primer. So a polyurethane primer is quite a bit different than a water-based. It's more of a resin-based, and it's a deep penetrating type of primer that can go in and strengthen and solidify the surface. And when you're doing these bond tests, you need about 3 days. You know, 24 hours is, you know, is a little bit premature. You can get some adhesive qualities in 24 hours. But I would recommend if you're doing bond tests to give it 3 days, like do these on a Friday and then come back on Monday, and you'll have some pretty good strengths and some pretty good curing out qualities. You don't have to wait 2 to 3 weeks to get good values, but at least 3 days gives you some pretty good values on these. So, and what you want to see here, you know, when we test floor coverings in the lab for performance standard, we're using a peel test machine that is all calibrated and it's bonded. We have a spot bond material, and it's hooked up to the machine, and the machine pulls up on it. Well, you can't necessarily do that on a job site. So what we're looking to identify here is when we pull on it, it's got to have some reasonably strong adhesive characteristics where, you know, it's a bit of a bear to pull it off the substrate. You can still get it off, but it's a bit of a bear to pull it off. And what we want to see is we want to see adhesive that is stuck to the substrate and adhesive that's stuck to the backing of the material, and that we've got proper transfer into it. Like, you know, you look at here, we're not tearing any of the substrate up. So the primer's holding very, very well. The adhesion was incredible, but we're also getting transferred to both the backing and the substrate. So it's called a cohesive break in here. So this is what we managed to get in this particular job. And so this allowed us to move forward with confidence that we had a primer that would be strong enough to solidify it and give us some strengths on the surface to allow for a proper mechanical bond and some performance here.
So Dave, describe the effort required to remove that pass of a sample.
Well, getting under it was the first challenge. So once we got through that, we obviously had to take you know, a screwdriver to get under it because the adhesion was pretty good, and it took quite an effort to do it. Like, I don't know how I'd explain that, but
3 weeks at the chiropractor.
Yeah, I didn't have to. Yeah, I didn't have to get my back cracked over it, but there was a bit of effort pulling it off. Which, you know what, that gave us some very, very good confidence in it. We did it, and I'll show you another job of another one where our first pull was kind of lukewarm for me, so we had to do a little bit of another preparation. So I'll show you that job in a bit. So this is what this polyurethane primer looks like over gypsum when you see it. So it's, and these are kind of newer primers that have been, they're not new, they've been out for a while, but, you know, the awareness that these primers exist, you know, is pretty lean. Not too many people know that there's another tool in the tool bag that's out there. They're not inexpensive. You know, for a water-based primer, you could be looking at anywhere between, you know, 5 to 10 cents a square foot, depending on what dilution rate you have. But with a polyurethane primer, you could be up to 40 cents a square foot. So they're not inexpensive, but they are a tool in the toolbox when you have a problem with a weaker substrate. But this is what it looks like. It's kind of a liquid plastic to it. You can patch over top of it. This is a bit of a rough first coat on here, but you can patch over it. And there's some instructions that your manufacturers would give you on timing on getting on it. Like in this case, we got onto it. There's a kind of a window that we try to get on as soon as it dries to the touch, like within a couple hours, we try to get on it and do our patching so that we get good mechanical adhesion to it. But also, like in the case of that apartment block, we didn't really have to do a lot of surface prep to it. And so we didn't really have to do a lot of patching. It wasn't mandatory. And in this case, we actually bonded the plank direct to that polyurethane primer. We just let it flash a little bit longer to get kind of in that 75, 85% range of flash. So we could still get the backing transfer, but still get really good drying out characteristics into it. So that's also a possibility depending on what you have, substrate condition wise. So getting into the flatness situation, just because gypsum products are pumped, you can't make the assumption that they're entirely flat. So, this was a particular room. Fortunately, we didn't see this throughout the whole building, but as soon as you walk in the room and, we have enough floor covering people here that, just by walking in the room, you can get the feeling right away. It's like, oh, this is not right. Like this is pretty far out. And then you start checking with straight edges and it's like, holy man, this is crazy. So like everything, you carry your straight edges, you check just to make sure that things are within tolerance. Because again, if this is a floating floor or this is a click floor, we're going to have some connection issues here. So, you have to make sure that our floors are flat and plain. And you can address these also by self-leveling if you need to. So I want to talk about that a little bit here too. So if you have to self-level a gypsum floor, in theory, you should use a gypsum product on top. And this gives you your best equilibrium. And like I mentioned earlier, gypsum doesn't shrink. So using a gypsum product on top of a gypsum product, you still have to have a strong enough substrate to stick it to, and you still have to have it primed properly. But at least a gypsum material is not going to put an undue amount of shrinkage and pull on a substrate. So we've done lots of applications with cement-based self-leveling on top. You can do that, but you have to make sure that you're using a cement-based material that is considered low stress. So what I mean by that is that what happens with cement-based self-levelers is that they are considered like shrinkage compensating materials, which means they expand a little bit and then they contract a little bit during the drying phase. And some products will expand and contract more than others. And especially the rapid set types of toppings, they're pretty aggressive and they can, as they dry, they can actually pull. And if you have a weak enough surface on gypsum, they can actually arc and tear the top layer of the substrate off. So not to scare everybody, but you just have to be a little bit more mindful on the strength of what you're going over and the types of materials and their limitations. So that's where you would get your manufacturer involved to come up with a solution. But certainly the use of gypsum toppings and gypsum self-leveling underlayments is one way of dealing with floor correction issues on this. And these are not your 80s gypsum materials anymore. So whether it be stuff that our company makes or other manufacturers make, these are all very engineered products that have high compressive strengths, excellent performance ratings, that you can do caster loads, you can do impact on them. They're also not susceptible to softening in the event that there's a spill. So, one of the concerns that, oh, gypsum materials are, they can emulsify in the presence of moisture. Well, that's not the case with a lot of these new high performance materials. This is not your 80s gyp anymore. So you can go to these with confidence, and they also are fast drying too. So you can get floor coverings installed. So it's kind of a new technology as well that is very well suited to doing gyp over gyp types of renovation things.
Dave, just be mindful of time.
Yeah, I'll try to finish up here pretty quick. So, and by the way, you don't have to pour these very thick. You can go to thin pour types of applications with these if all you're trying to do is resurface an area. Another thing I want to talk about real quick here is optics. So as good as we can patch, sometimes you'll get these type of imperfections that show in the right lighting. So you can imagine you skim, you sand it, and then you skim again, and then you sand it. As good as we can do hand prep, sometimes you'll get these types of optics. So when you're doing thin pour types of self-leveling, you'll get a much more truer optic that you'll see in the surface. But in addition, you'll get truer drying out characteristics for your adhesives, and you'll have a better, more consistent canvas, generally speaking. That's not to say that we need to replace patching, but there is new technology now that you can get some pretty smooth floors without having to go through a sanding and hand prep process. So, for example, here's one, and this is a gypsum topping that is put down at 1/8 of an inch over a gypsum pour, and a water-based primer was used here, and you have a perfect canvas to install floor coverings on that is very high compressive strength and is super flat and super smooth for floor covering installation. And you can pour this in a pretty fraction of the time if you need it. This was a crazy one, and I'm showing you this one because this is actually not a gypsum floor, but you would almost think it is, and you can see how pitted and how damaged it is. This was a cement-based self-leveler, but it was also one of these site pour systems. So the manufacturer supplies a concentrate, and they mix it and they pump it on site. And their compressive strength came out very low as well. But this was a commercial job. So this is like 25,000 square feet of LVT and carpet tile. And what we actually had to do here before we put the polyurethane primer was actually run a buffer over the surface and remove all this latence. It was kind of like latex migration in the product that came to the surface. So we had to break that surface first before we put the polyurethane primer down. And so on the left here is what you see, the polyurethane primer. And then we had to do 2 thin coats of patch and then the installation of LVP. So came out very good. You can see the scissor lifts here on the left-hand side and typical, store shelving being set up. This was a very successful installation that's been down for a couple years now. And so it can be possible on a case-by-case basis that we can deal with some of these site issues better than we used to be able to a number of years back. So I'm getting near the end here, guys. So just to recap, whether you're the flooring contractor or you're a manufacturer of materials, we all have risk in this and we all have skin in the game. So if I can, just kind of put a checklist together, is inspect the pores, even if it's a cement-based material, check to make sure that it is what it's supposed to be. Get a copy of the PDS of the product because there should be a design mix, or there should be, a recommendation or a specification in place for what was supposed to be there. Check it for hardness, check it for moisture, for flatness. Do your bond tests and mock-ups in advance. And if you have any concern, then start to raise some white flags. And also get your suppliers involved too, you know, whether it be your installation systems companies or your flooring suppliers, because your flooring suppliers also carry weight, and they can also, you know, throw up a white flag to say, hey, this substrate does not meet our recommendations. You know, we've got a significant amount of material going into this project, and, you know, we don't want it to fail. And, you know, we need to make sure that it meets our criteria too. So, you know, getting kind of a team huddle involved in these things makes a big difference, so that it's not just all on the flooring contractor having to deal with it. So hopefully, like, I covered some stuff here. So hopefully you picked up a little bit about some new things and some ways around it. In my experience, not every job is the same. There's always some little nuances that are a little bit different. But yeah, if I can help, that's what I do, is I get involved in some of these things. So if you have some questions now, I'm open to take that now, Chris.